We start that question again. Exercise 11C 4D. The integral of x plus 1 squared x dx. So because this is a power of 2, it's not a log function, okay, and it's not even down in the denominator. So the first thing I'm going to do is expand that bracket, x squared plus 2x plus 1, and I'm going to write the denominator on each one. Okay. And now I can simplify that. So this x cancels with this, cancels with this. So at the end now I have the integral of x plus 2 plus 1 on x dx. Okay, so I'm going to integrate, I'm going to write the answer up here. So this becomes x squared over 2. The next one becomes 2x. And 1 divided by x, now that becomes a log, plus log e of x, and I'm going to put plus my c. Any questions on that one? Now, hopefully we didn't lose the video of the other one. That would be disappointing. Okay, my next question that I'll be doing is 11F 8B. Probably should have done them in order, but I just wrote doing them as people giving them to me. So, all right, so let me just clear this one. Everyone finished copying this one down? Okay. So this one is exercise 11F, question 8B. Now, 8B, so in the first part it just told you to evaluate that, that's not a problem. But in 8B we have the picture. Okay, so I'm just going to quickly draw this. It's not going to be my best drawing. As you guys know, I'm a very artistic person. Okay. That's all right, don't laugh. So it's going to come through like this and down like this. This part is shaded from there to there. That part is shaded and this part is shaded. This one is -1. That, of course, is 0. And that one there is 3. And this part here is 4. Okay. Now, this part and this part here is under the graph. And this one is 1 unit. And this part here is 1 unit. Between 3 and 4 is 1, and between 0 and -1 is 1. So all I'm going to do on those parts, and being under the graph, these are negative. Negative. Okay? So because they're negative, I've got to compensate for that negative. So this area is going to be 2 because of these two, both being under the graph. I only need to work on one, so I'm going to do this one here, -1 to 0. I could do 3 and 4 separate and not have the 2 there, that's fine, but I'm only going to do it like this. And the rule is, we can see in part A, x3 minus x dx. But I have to add this other part here. I haven't done anything between 0 and 3. So now I'm going to add the integral between 0 and 3. Of course, the same rule, x3 minus x dx. Any questions up to there?
Wait, where'd you get the 2 from?
The 2, because I'm doing this one. 1 unit here between 0 and -1 is equal 1 unit. And this one here at the same time between 3 and 4 is 1 unit. So instead of doing them both, I can just, because of the same width, I can just times by 2.
Okay, makes sense.
Okay, so now I'm going to integrate. Okay, so 2, oops. Okay, oh, I should have expanded this one. I'm just going to expand it underneath. 3x minus x squared. So I'm going to integrate that one. I'm going to get 3x squared divided by 2. Integrating this one, x cubed divided by 3 between -1 and 0. That's the same integration because it's the same graph. But this time it is between 0 and 3. Okay, I'm going to write a little bit smaller or we're going to be in trouble. Okay, So this becomes 2. 0 in there is going to give me 0. So forget that. There it is, 0. Minus, putting the negative 1 in there. Negative 1 squared is 1, so this becomes 3 on 2. Minus, putting the negative 1 in here becomes negative a third, so this becomes plus a third. Everyone agree there? Now I'll do the next one. Plus, putting the 3 in. 3 squared is 9 times by 3, 27 over 2. Minus, 3 cubed is 27 over 3. Okay, minus, putting the 0 in there gives me 0 anyway, so there it is there. Okay, got to get the same denominator. So the denominator here is going to be 6. So this becomes, times this by 3 gives me 9, times this by 2 is 2. That will be over 6, so this gives me negative 11 over 6. Okay, plus this one here, times that by 3. Okay, timesing that by 3 is going to give me 81 over 6. Timesing this by 2 is going to give me 54 over 6, and that's zeros. Now, 81 minus 54. 81 minus 54 is 27. Over 6. But I need that plus there because it was plus 0. Okay, I've got to do the 2 times this first. So, because it was negative, I better put a negative under there because these graphs are underneath the x-axis. And if I don't put my negative, that means I'm going to get a negative answer. So I'm just going in and put my negative, so that's a negative 2. So this becomes 22 over 6. Plus my 27 over 6. So 49 over 6, which ends up giving me 8. That's 48 and 1/6 units squared, because it is an area that I'm finding. 8 and 1/6 units squared. Any questions on that one? Make sure you go back and put your negative, please, because I had to go back and put my negative in it because I forgot to put my negative at the start, even though I said it. And I would have seen that because if I didn't have the negative, then when I go and times these together without the negative, I would have got negative 22 over 6. And remember, you can't have a negative, you're adding the total area. All right. I'll clear it in 10, 9, 8, 7, 6, 5, 4, saying that exercise 11G question 2I. 11G question 2I is going to be our next one. 11G question 2I. Get rid of that since they keep popping up. Okay, so I'm going to clear this now. Okay, so exercise 11G question 2I. Okay, it says find the exact value of these intervals. Okay, which question 2I is the interval between 0 and pi over 4 of sine 2x minus pi over 3 dx. Okay, when I integrate sine, remember, I first need to do the derivative inside here, and the only x value is there. So in differentiating that 2x gives me 2. And remember, it becomes 1 divided by the 2. But now I've got to differentiate sine. Differentiating sine gives me negative cos. So I'm going to put my negative, there's my cos, and I still have the 2x minus pi on 3. Okay, put my square brackets around all that, between pi over 4 and 0. I can take out the negative a half, I don't need it. Okay, that's just a constant. I can keep it in there, it won't matter, it's just a little bit more work. So I'm going to keep it in there for this one, and the next ones I'll take it out. So this becomes negative a half cos. Okay, 2 times pi on 4 is going to give me pi on 2. I've still got my minus pi on 3. Then I've got a minus the 0. A minus, okay, negative a half cos. Putting my 0 in there, 2 times 0 is 0, so this becomes negative pi over 3. Okay. This is negative a half cos. I'm going to get a denominator of 6. Okay, so 6, which means this is a 3 pi, 6, which means this is a 2 pi, and I'm going to work that out. So 3 minus 2 becomes pi over 6. Minus, and another minus gives me a plus. So I get my half cos of negative pi over 3. Okay. Any questions at the moment? I'm going to continue with the question up on the side. Okay, so this gives me negative a half cos of pi on 6. Cos of pi on 6 is square root of 3 over 2. So this becomes times the square root of 3 divided by 2. Plus my half cos of negative pi over 3. Now I'm just going to quickly draw it down here. There's my quadrants. Negative pi on 3 is down here. Cos in that quadrant is positive. So this is really just cos of pi divided by 3. A negative won't matter. Now cos of pi on 3. Cos of pi on 3 is a half. So this becomes times by a half. Any questions there?
No.
Okay, simplifying this, this is negative the square root of 3 over 2 plus 1 over 2. Putting it on the same denominator, I have 1 minus the square root of 3 all over 2. That's a bad square root of 3. 1 minus the square root of 3 all over 2. Oh, they're 4s. Oops, you guys didn't even see. 2 times 2 is 4. Let me erase that, erase that, erase that. That becomes a 4. 2 times 2 is 4. 2 times 2 is 4. That's all over 4. The answer's still the same. It's just over 4. Okay. Any questions on that one?
No.
My next question will be 11G, question 4B. 11G, question 4B. Okay, is anyone still copying that down? I'll give you about 10 seconds. Okay, here it comes. It's going to get cleared. Okay, exercise 11G, question 4B, which says, for each of the following, draw a graph. I'm not going to draw a graph for you guys. Illustrate the area given by the definition and evaluate it. So, integral between 0 and pi over 3 of sine 2x dx. Okay, integrating sine, we'll first differentiate in here, becomes 2, so this becomes a half. Integrate sine, you get negative cos of 2x. Put my square brackets around it between 0 and pi on 3. Okay, I'm going to take out the negative a half. I don't want to do it. Okay, so it's really cos of 2x between 0 and pi on 3. I can take that out. That's just a constant, so we can times it in later. Okay, so this becomes negative a half cos 2 times pi on 3 is 2 pi over 3 minus cos 2 times 0 is 0. Okay, which gives me negative a half cos of 2 pi on 3. Now remember, 2 pi on 3 is here. in the second quadrant, and cos in the second quadrant is negative. Okay, so how do we get to 2 pi and 3? Really, we're going to get to the pi, and we're going to take away to go backwards. So it's going to be pi, and we have to take away pi on 3. So that's what we're going to get there. That's what we're going to write. We're going to write negative cos of pi over 3 minus cos of 0. Well, cos of 0 is 1. I can just write that 1 there. Okay, I'm doing this extra step so you guys remember how to do this. Okay, so now I can continue. Negative a half. Cos of pi on 3. Cos of pi on 3 is a half. I've still got my minus 1. So this becomes negative a half times negative a half minus 1 is negative 3 on 2, negative 1.5. So negative 3 over 2. Two negatives are a positive, and then this becomes 3 over 4. So 3/4 is my answer. Any questions on that one there? Okay, the next question, same exercise 11G, but it is question 4C. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, I'm going to clear this. We still got to do one here. Let's have a look. Yeah, everyone's still there. Don't forget you can put your hand up on the reactions there. Oops. Okay, so exercise 11G, question 4C, which we're still doing the same thing, but this time it's the integral between pi on 6 and pi of 6 of cos 2x dx. Okay, so integrating the cos. First differentiating in here gives me the 2, so it becomes 1/2, because it's an integration. Integrating cos gives me positive sign, so I've got positive sign of 2x. Between pi on 6 and negative pi on 6. Okay, substituting in. This time I'm going to take out the factor again, and I'm going to substitute in at the same time. So I get sine 2 times pi on 6 gives me pi on 3. Minus sine 2 times negative pi on 6 gives me negative pi on 3. Okay. Still got my half. Right, sine pi on 3 is, remember you've got to know your triangles or your rules, square root of 3 divided by 2. I'll just draw the circle down here again. Remember C-A-S-T, negative pi on 3. Negative pi on 3 is down here. So sine in that quadrant is negative. So this one's going to be plus, because 2 negatives become a positive of sine pi on 3. Now again, you don't need to write this line. Okay, so now I've got square root of 3 on 2 plus sine pi on 3 is square root of 3 over 2. This equals a half times 2 to the square root of 3 over 2, because 1 square root of 3 plus another 1 square root of 3 gives me 2. They cancel. So you've got the square root of 3. I don't like that square root. Square root of 3 divided by 2. Okay. Make sure you ask questions, please. Any questions so far? So I'll clear it in 10. There's 2 more questions that I've got asked that I've got to finish. The next one is 5A from the same exercise, 11G. So this is exercise 11G, question 5A. Okay, which says, find the exact value for each of the following definite integrals. So this is the integral.
I said my thing's broken, so believe me.
Between 0 and pi on 2. Whoever's talking, you might want to mute your mic because we can hear it.
Oh my god! Miss Edmonton's doggy is so cute. She was, her dog was wearing a hoodie because it was cold.
What is it?
She
Is
showed
it a corgi? Is it a corgi?
Okay, so sign.
What color was it?
Who's talking to their mum? Whoever's talking to the mum,
Color?
either put your mic on silent or stop talking to your mum. Okay, sign 2x plus pi over 4 dx. Okay, so doing this one again, I'm going to differentiate inside the bracket, so that gives me 2, so this becomes the half. Differentiating sign gives me the negative cos, so negative cos of 2x plus, God, that's a pi over 4. Pi over 2, 0. Again, I'm going to take out the negative. Okay, and substitute the pi on 2 in, so we get cos. 2 pi times pi on 2 gives me pi, and I've still got my plus pi on 4. Minus, substituting my 0 in gives me cos. 2 times 0 is 0, but I've got my pi on 4. Okay. Simplifying this before I try and work anything out, this is cos 5 pi over 4 minus cos pi over 4. Now remember, cos of 5 pi and 4, if I do my quadrants, pi is there, 5 pi and 4 is down here. So really, when I work this out, I'm really just working out cos of pi over 4, okay, because the pi is going to be taken into consideration. So I've got the negative a half. Let me write that again. I've got negative a half. Okay. I'll write it at the moment. This is cos of pi over 4 minus cos of pi over 4. Oh, and remember, I've got to put a negative in here because of it being in this quadrant. I was looking at it and going, that's going to just cancel. Okay, so this gives me negative a half. Negative cos of pi and 4. Pi and 4 is 1 on the square root of 2. Minus cos of pi and 4 again, so 1 on the square root of 2. I've got my negative a half. Minus 1 is minus 2 on the square root of 2, so times minus 2 over the square root of 2. Working that out, the 2's cancel, the negatives cancel, so I'm going to get 1 divided by the square root of 2. Now, they probably have written it that the denominator is not a surd, so to remove the surd, I'm just going to times both the numerator and the denominator by the square root of 2. So I get the square root of 2 divided by 2. So it could be either 1 on the square root of 2 or 2, square root of 2 divided by 2. I'd say they'd give you the second one, but I could be wrong. Any questions on that one? My last question to do with you guys that have been given is 11G, question 5D. 11G, question 5D, which is continuing from 5A. 10 seconds, but if I hear anyone, I won't clear it. 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so exercise 11G 5D. This is the integral from 0 to pi on 4 of cos 3 pi minus x dx. Okay, same thing. Be careful here. The x is only there. It has a negative 1 in front of it. It's not the 3 pi. So some of you might look at the 3 pi and differentiate the 3 pi and get your 3. That's wrong. There's the x. So the only thing that I get here when I differentiate this is negative 1. So I'm going to get negative 1 divided by 1. Okay. Differentiating cos is a positive. So there it is, sine of 3 pi minus x between pi on 4 and 0. Okay, I'll take out my negative 1. There it is, sine. Okay, 3 pi minus pi on 4 minus sine of 3 pi minus my 0. There's my negative. Remember, I only subtract fractions when the denominator is the same, so this is going to be 12. Okay, so this becomes sine 12 minus, how can it be running out of time? 12 minus 1 is 11 pi over 4 minus sine of 3 pi. Now 11 pi and 4 is really twice around the circle and another 3 pi. Now 3 pi, remember, is in here, 3 pi and 4, so I've got to get to the pi, and I'm going to take away pi on 4 to give you my 3 pi over 4, because that's what that is. 11 pi on 4 is 8 pi and another 3 pi over 4. This part we don't worry about, it's just going around the circle. So it's just that, and that really is in there. So this is going to be, and sign in that quadrant is positive. So this is going to be in the negative, sine of pi over 4 minus sine of 3 pi. This becomes negative, sine of pi on 4. Pi on 4, 1 on the square root of 2. Sine of 3 pi, now remember, that's over here. That's the point negative 1 and 0, because that's where pi is. Sine of that is 0. So minus 0. Well, this just becomes negative 1 on the square root of 2. Okay, there's that answer there. I've answered all the questions that people have sent to me. So considering how long we've been going, if there's any others that you want me answered, please email me. I'll work out the solutions and then we'll continue from there. Our next exercise will be 11J. Okay, I think that's going to take us a little bit of time to go through. Okay, but if we have to, we'll take it in stages. It's actually not that bad, but it does involve a bit of physics stuff. So be wary for that, ready for that. Any questions before I say let's sign off? No, thank you everyone.
Sir,
yep.
Just a quick question about our next topics for
Mhm.
term 2. Do you have like any of the booklets?
Yes, I will email you. No, I won't email. I'm going to put them on Google Classroom.
Okay.
Okay. I'm going to do that today. Chapter 1 is our next one, and then chapter 3. Okay.
Thank you.
All right. No worries. All right. See you all. Good luck, and I'll see you in our next lesson.